And last of chapter 7. Some fun calculations here, scientific notation. Number sense, this is important things. Why do we use scientific notation? We use scientific notation because it's a simple way to write an extremely large number or an extremely small number as a more manageable way of writing it, and it's using base 10 powers. So we're going to take a number and we're going to scrunch it, and we're going to keep track of how many place values we move. So one place value is 10 each time. So that's 1, 2, 3, 4. And why did I stop there? Well, because when I stop between there, that number is between 1 and 10. So this base number needs to be always between 1 and 10. And then I'm multiplying it by 10 to the, how many 10s did I move? I moved 1, 2, 3, 4. So 10 to the 4th. So this is where the bigness went. So we made a big number small. So notice we had 27,000. We made it small. So where did that bigness go? It's like a balloon. When you squeeze a balloon, that air needs to go somewhere. So when we squeeze this big number, where did the bigness go? Well, it went in that base 10 power. So we're going to keep track of the 10s that we write, and it's 1, 2, 3, 4, 5. That's 36. Now it's 3.06. I couldn't stop when it was when the number was 30 because it's not between 1 and 10. So we have 3, 6, 3, 4, 5, 6. So that's times 10 to the 6th. So the 10 to the 6th is 1,000,000. So if we multiplied 1,000,000 times 3.06, we would have gotten 3,060,000. So we're going to 1, 2, 3, 4, not between 1 and 10, 5, no, that's 250. 6 is 25, still not between 1 and 10, 7. So 2.501 times 10 to the 7th. Cool, understand? Now we're going to write, now we're moving in the other direction. 1, 2, it's 0.3, 3. Now it's 3.05. We're still moving the decimal point until it gets between 1 and 10. And I moved it 1, 2, 3. But this time, I made a small number big. So where did the smallness go? Well, that's why we do negative power of 10 to the negative 3. Because 10 to the negative 3 is a really small number. That's 1 over 10 to the 3rd. So here is where the smallness is represented. We made a small number big. Where did that smallness go? This is the smallness. I don't think anybody's ever taught it in that manner. I think this is a good way to comprehend it, to visualize it in a way. 1, 2, 3, 4, 5 is 0.17. So I got to move it a 6th time. That gets it 1.7 times 10 to the negative 6th. 1, 2, 3, 4, 5, 6, 7 times 10 to the negative 7th. And that's all you're doing. It's really all you're doing. Write each number. Now we're going to expand it. So when we expand it, remember, this is making something big. So we're going to take this small number and we're going to move it 7 places to the big. So making it bigger would be moving it to the right. 1, 2, 3, 4, 5, 6, 7 decimal places. That's where my decimal point will now be after. And now I'm going to place zeros for each of those gaps. And every 3 will have it. So that is going to be 30 million. That's what it is expanded. So I have 2.27. I have to move it 8 places. This is a big number. 1, 2, 3, 4, 5, 6, 7, 8. That's where my decimal point now is. I'm going to put zeros in there for each of those lollyloops. there's a comma, so 227 million. That would be my answer. I have 11 places. Come on. 4.6. I got 1, 2, 3, 4, 5, 6, 7, 9, 10, 11. I got that many zeros. This is where you kind of tend to make mistakes. There's a, yeah, it doesn't look like a comma. Oh! So let's use a different color. That's a comma. That's a comma. Every 3. So 460 trillion. See, ran out of space. Let's make it smaller so I can get my zeros in there. Pain in the butt. 460 trillion. No, billion, sorry. Uh-oh, did I forget a set of zeros? That's million, billion. 460 billion. Yeah, that's good, sorry. All right, we're good. Now, we're still write each number in decimal form. So we're still moving the decimal point. 1, 2, 3, 4, 5. Adding zeros for each loop. And that's 180,000. That's easy. Now we're going to move it small. So we got to make it smaller. So we're going to move 1, 2, 3, 4, 5. We'll add zeros in there. So we have 0.0000529. We have 6.0. We're going to move it 8 places. 1, 2, 3, 4, 5, 6, 7, 8. 0, 0, 0, 0, 0, 0, 0. 0.1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 6. We don't write this 0. That's not going to be needed. Write each number in expanded notation using powers of 10. This is the most bizarre thing. I have never seen the reason why we need to do this, but I get it. We'll do it. So that's 1,000 plus 700. So 1,000 is, how do we write it? 1 times 10 to the third plus 7 times 10 to the second. That's how you write it. So dumb. So this is 4,000 plus 800 plus 10 plus 2. So that is 4 times 10 to the third plus 8 times 10 to the second plus 1 times 10 to the first plus 2 times 10 to the 0. Do they do the 0? Let's look. What do they do? Yeah, 10 to the 0. Nice. I love it when they do it properly. All right, so this is 0.1 plus 0.04 plus 0.003. So how do we write that? 1 times 10 to the negative 1 plus 4 times 10 to the negative 2 plus 3 times 10 to the negative 3. I mean, it's so weird. Why would I want to write this? 0.07 plus 0.005 plus 0.0006. So that's 1 times 10 to the negative 1 plus 7 times 10 to the negative 2 plus 5 times 10 to the negative 3 plus 6 times 10 to the negative 4th. Don't know how that works. So this is 30 plus 6 plus 0.07. So this is 3 times 10 to the second. No, 3 times 10 to the 1 plus 6 times 10 to the 0 plus 7 times 10 to the negative 2. 100 plus 70 plus 5 plus 0.1. This is 1 times 10 to the second plus 7 times 10 to the first, plus 5 times 10 to the 0, plus 1 times 10 to the negative 1. Probably the most non-useful, let's spread that out a little bit, non-useful understanding of, or piece of information that you're going to learn that you probably will not. Now, don't get me wrong, there might be some book times 10 to the 5th plus 3 times 10 to the 2nd plus 9 times 10 to the 1st plus 6 times 10 to the 0. There may be some assessment that wants you to write it in expanded notation. I feel sorry. 0.006 plus 0.0001, that is going to be 6 times 10 to the negative 3 plus 1 times 10 to the negative 4. I think that, did we go to the 100th place? Oh, no, that might be 10th, 100th, negative 2. Oh, that's the 1000th place, so that's correct. 6, oh, let's do this. How many more of these we got? Oh, we've got a lot. All right, there's something else coming. 60,000 plus 4,000, and that's 6 times 10 to the 5 plus 4, no, 10 to the 4 plus 4 times 10 to the 3. 3 zeros. And this is 0.0003 plus 0.00002, and that's 3 times 10 to the negative tens, hundred, thousands, 10,000s. Four? All right. 10,000, yeah, 4. Plus 2 times 10 to the negative 5. So how many more? Okay, good. Thank goodness. This is not really what I want to be spending my time on. That's for sure. Because this is futile and silly. 1, 2, 3, 4. 1, 2, 3, 4, 5. 1 times 10 to the negative 5 plus 5 times 10 to the negative 6th. Pretty sure I figured that out, right? 1, 2, 3, 4. Yeah, until you make it. Sorry. That's good. Oh, my goodness. 80 million plus 5 million plus 20,000. So that's 8 times 10 to the 6, 7 plus 5 times 10 to the 6 plus 2 times 10 to the 4. All right, this is the one that I like. So when we have this, this is the cool part. So we can do this in our calculator. We're going to do this part in our calculator. And then we're going to do this like we divide like bases. So 1.5 goes into 6 divided by 1.5 gives us 12, oh, not 12, sorry, 3 times 10 to the 5 minus 2, which is 3 times 10 to the 3rd. So instead of pushing those values out into expanded form or numeric form value, we can do a shortcut. We just do the division. 6 divided by 1.5 gives us 4. That was the easiest part. No, the easiest part is dividing like bases. So we have that. So when we multiply, we're going to multiply these. We're going to multiply the bases. And then we're going to add, because we're multiplying like bases, we will add those exponents. So 4 times 1.6. So in a sense, we're multiplying 4 times 1.6 times 10 to the negative 6 plus 8. So that's 24. That's 6.4 times 10 to the second is going to be our answer. So no calculator that time. So we're going to do 6 times 7 times 10 to the 6 plus -2, which is 42 times 10 to the 4th. Now this number needs to be between 1 and 10. My decimal is here. So I'm going to have to change this because this is not scientific notation. That's where we scientific. So we get 4.2 now times 10. Now where does that 10 go? Well, we made a big number small, so where'd the big? We have to represent the big, so we increase that by one more 10. Don't know if you see that. So we have 1.25 times 12, which is 5/4, 15, times 10 to the 4 plus 3, which is 15 times 10 to the 7th. And then I have to convert that to scientific notation. So I get 1.5 times 10 to the 8th. Nice, right? I mean, it's pretty cool. Ah, I like this. So let's do this. Let's multiply these two first and get a value. So we have 2 times 10 to the 4th over, we got 20 times 10 to the -2 plus 1, which gives us 2 times 10 to the 4th over 2 times 10 to the, I moved the decimal over, so that's bigness. That's -10 to the 0. So that equals 2, because I had to move it. So that equals 1 times 10 to the 4 minus 0, or so that equals 1 times 10 to the 4th. Kind of cool. Kind of neat. I think that's right. Pretty certain. We get 28 times 10 to the 4 plus -2. 28 times 10 to the 2nd. Move it one place, 2.8 times 10 to the 3rd. Why'd they go back to the easy part? I have no idea. But this was a quick video.